Okay, we got our drain valve in there. Everything looks okay with the joint itself, all the way around and underneath. That sucker's in there solid. So now it's leak checking time. You could obviously pump this up with compressed air, use some soap bubbles of some sort. But what I'm going to do is what I have it hooked up to right now is my vacuum pump. So I'm going to draw the air out of it. That's going to do two things. It's obviously going to let me see if I have a leak in it. If I pull as much air out of it as I can and close everything up and seal it up and see if those gauges move. If they do move, I obviously have a leak in the pressure tester with some nitrogen I have in my truck. But this will basically suck all the air out of there, and will also, if there's any moisture in this tank, it'll boil it off, because you're dropping the pressure so much that the actual boiling temp of water is lowered. So if there's any moisture in this tank or anything, it'll boil it right off and come out as vapor on this machine. My little rubber is missing on the front. So we'll see what the results are of that. In the meantime, I'll let this pull down, and I'll get as much out of it as I can, and then we'll shut it down and put this aside, and we'll start working on the electrical and getting that set up. Okay, let me show you what we got going on here for electrical. We have our main power coming in right here. On the other side of this, there's a box with a switch that's fed from a cord cap. Now down here we're coming with that main wire into our junction box. From here we're going to have power go to our pressure control. From the pressure control back to this box, which is going to be junctioned in with the compressor here. And then your neutrals are all going to be put together. So let me see if we can zoom in here a little bit. So we got our main power in here. Our main power first is going to go to a leg from our pressure control, or going to our pressure control. So these two here going together. And what I do with my lemons and my wire nuts. Okay, there's power going out to my pressure control. We're going to come back with power from my pressure control, and we're going to go to my compressor. And power neutral's coming back from the compressor, going back to our main neutral here. That's it, and all these will get tucked all nice into that box. I just got to get a 4-inch cover for that. I don't have one. Now, if you notice, all the wire that I used is stranded because all these junctions here have solderless connectors or stake-ons that go to screw terminals. You could also use solid wire, but it's more of a pain in the ass. You're better off just using stranded wire with a crimped on connector going right around the screw. Especially on controls and stuff like this, you don't want a solid wire on there because they don't give you enough room to get that in there. So let me just go to the compressor here to show you one thing about that. Okay, we're back at our compressor side here, and we took the cover off the compressor. So you can see we got the capacitor, we have a relay, and this right here is a thermal overload. This is touching the compressor. If this compressor gets hot, that's a bimetal snap disc back there. I know it's kind of hard to see. This right here, that's what that is. And this right here is called a current relay. This is what drops the start winding in and out. And basically what happens is this compressor tries to start, it can't. So it draws a lot of amperage, which then energizes this coil and pulls a set of contacts together, kicks in the start winding, then the amperage drops, which de-energizes this coil. Those contacts separate and it drops out the start winding. The problem with these is that you always have this open close, open close, open close, open close. Every time it does that, what happens is you get a small arc when it does that every time. So and now you're doing that under a decent load. You're doing that under a starting load. So what happens is eventually those contacts either weld together or they never close. And you'll go to a call and your compressor's not running, and you'll just hear kind of like a hum and a click. That hum is the compressor trying to start. That click is this relay trying to open up. Usually you can replace these, which is with what's called the 3-in-1, which is a solid state relay. Instead of being mechanical with contacts, it's actually a ceramic disc. And you'll a lot of times be able to bring the compressor back to life. But anyway, as you can see, these slide right off, and there are your 3 terminals. This here is your common. One of these is a start winding, one of these is a run winding. One way you can look at it is if you look at the relay here, you see S and M. That's start winding, that's main winding. So from here to here is your start winding, and from here to here is your run winding. If you didn't know that but needed to find out, you can ohm it out. Your largest resistance will be between your start and your run. So in other words, if you go between here and here, and that will be your highest resistance reading, that means that what you're not touching is common. If you go from here to here, which would be, on this case, your start winding, this from here to here would be higher than your run winding from here to here. So basically from run to common will be your lowest resistance reading, from start to common will be your highest, and between start and run will be your highest. Now when you hook up power to this, your neutral you want to put to your relay here. It doesn't really matter, it's not like they're polarized, but what happens is if you put power here, that always has the power leg to it. So if this, your power lines go between right here, which is on your overload, and your relay here. So if you were to put your actually main power in on this, power goes to the compressor first before it gets to the overload. So basically the overload is breaking the neutral. You don't want to do that. You want your overload to break power into the compressor. So always put the actual power leg on the overload. So we'll put our neutral right here. Sometimes these are kind of fussy, and you have to, depending on how big your stake on is here, you might have to finagle it just to here to get everything to fit in there nice. And this right here, let's slide this out the way, will be where our power goes in. I gotta get on the other side of the camera. And I just knocked the overload off, but all it does is this is kind of a piece of spring steel here that holds pressure on 2 grooves. It'll hold pressure against that to the compressor there. Now my ground, I just put a self-tapper right in there. A lot of times these compressors don't have a hookup for ground, but I just made one there. And the covers here, you can see this slot. that slot cut out, it is there for your wires to go through. So kind of tuck your wires in underneath here. They go through that slot. Which, like I said, sometimes why you have to bend the stake-ons just a hair. Get everything to fit in there nice, and then it's held on with this little spring clip that hooks in a notch in the bottom somewhere, right there, and onto the top, which they're always a pain in the ass to get on, especially after you shove all the wires in there. There it is, and then that holds that wire nice and tight. Now this is long so that I can strap it down somewhat like that, because our tank is going to sit right here, which has been holding pressure for the past 45 minutes or so. So we definitely don't have a leak in that, so we can put that in place and start piping this bad boy in. We're still holding the vacuum on the tank, and that's right where it was when I shut it off, so we're good to start putting that together. So let me get it in place, and we'll kind of go from there. Okay, we're kind of looking straight down to the best view that I can get here. This is the discharge port. It used to come straight out at a 90-degree angle, or parallel to the ground. I bent it up as best I can without kinking it to about a 45-degree angle. That'll help keep, if it does pump any oil out, to kind of sink back down into the compressor. What we're going to do is take this discharge line. We're going to go up here, and then we're going to go over, and down, or maybe even a 45. So we'll go up, over, down, and into here. So it's going to be an upside down U. That way there, I have a decent vertical run, so if any oil comes out of there, it'll hopefully migrate itself way back in. And also in line with that on that vertical, before we 90 over, I'm going to put this, and what this is a refrigeration filter dryer. Now what this has in it is a mesh screen, then kind of like a cotton pad, and then desiccant in here in a solid core. Now obviously desiccant is meant to remove moisture, and desiccant does get used up, it does get saturated, and this can't be replaced, but I really don't care about removing moisture at the moment. What I'm using this for is kind of like an oil block. If any oil kind of migrates up or gets mixed in with the air that's being compressed, hopefully this will catch it and hold it and let it drive back into the compressor. So that'll be probably right around here somewhere. So we're going to go up and then into the bottom of this, which obviously has a direction, and then we'll 90 over to here, 90 down, and then 90 in. And it'll be 1, 2, 3, 4 joints. Flare nut there, a joint here, a joint here, and a joint there. It's all going to be 1/4 inch soft drawn tubing. The 90-degree bends will be bent with my tubing bender. This one here I'll probably just gently slope by hand, so that way there I kind of have a nice gentle curve, so if oil can go back in, it's not going to get caught in any kind of bends. So let me just measure it out here a little bit, and we'll kind of get this figured out where I got to cut it, and I'll bend it up. I'll show you a little bit of bending, and we'll get her in there. Okay, here's my dryer. I have it up against the edge here because there's a hole right here. I can put a zip tie in there, get that nice and secure. I did solder the joint on the compressor here just so it's not all wiggling around, because I did unsweat this, so I had to reheat it to put the pipe in. So that's all set there. So we want, say, about from here to here, about 11 inches or so. We'll 90 down and then 90 that way, kind of 90 and then 90. So I'm going to bend a tight 90 for here, because I only have, say, about 4 inches here, so bend a nice tight 90 with the tubing bender. There to there we want 11 inches is where we want to start around 90, other 90. We measured that, that's bending to the right, so we'll line up the R and we'll bend another 90. And then we'll just cut a piece a little bit long here, just so we're not working with a whole roll. Ream out the end a little bit. The end of this one. Okay. I get a piece of sandcloth. I'm going to sand the end of this. The other end here is already clean. The wire brush. We'll put a little bit of flux on here. Get that in place. And then this, we want a 90. Let's see. What we want the start of that to be. And then there, 9 inches from the top here to where we want the other 90. Now you can measure these and use the 0 mark, the R mark, the L mark to subtract and add whatever way you do it, but what I like to do, since I know I got to be 9 inches, you can follow the sweep of the 90 pretty easily. So I got to be 9 inches from there to there on center with that pipe. So we're about there. And there's our other 90-degree bend. It should put us directly in line. I'm just going to bend it towards that line. Oh, put a little kink there. Right there. Perfect. Now that, we're going to put our flare nut there, so we're going to cut it right where my finger is. Quick little ream. Quick clean. My flare nut swivel is already clean. I'll put a little bit of flux on the end here. Have a swivel in place. Put this piece in place. And put that right in there. And there you go. That's our piece. So now we'll solder everything. What I like to do too, solder will flow wherever you put the heat. But if you're a little bit shaky, say you haven't had your coffee in the morning, just take your flux and give just a slight coat on the top of your joint or whatever it is, you know, if that's a coupling or whatever. So when you heat it, if you miss, if you say hit the fitting instead of the joint itself, it'll roll itself around and draw into the joint. Just a little trick. Now the hardest joint in all this is going to be the one on the bottom. That's the one that you tend to get drips on. So let me see if we can zoom you in here a little bit maybe. Maybe we'll see, we'll do this one first here. Now whenever you solder, you heat the joint. You don't heat, you heat the fitting. You don't really need to heat the joint. You want to heat the fitting, and you don't want to heat the solder. So you'll see I'll have the heat on the bottom here, and what that's going to do is that'll heat the fitting, and when I touch it, capillary action and everything else is going to want to draw that solder into the fitting itself. This solder will flow wherever you put the heat. So you want the solder inside the fitting, so you want to heat the fitting. And I'm just using a MAP gas tank here. That's all there is to it. And you'll notice, how do I say this without pissing people off? You can tell a refrigeration tech's solder joint from a plumber's solder joint. A refrigeration tech solder joint will look exactly like that. A plumber's solder joint will have more of a solder smear. In other words, it'll be a really thin coat, probably from here to here. The reason why is plumbers tend to carry wet rags with them, and while the solder is still wet, they wipe their joint, which spreads it out over the entire joint. Refrigeration techs don't do that because moisture is pretty much your enemy. You don't want any moisture in that. Refrigeration techs will go over this with a wet rag, but after the solder is hardened and after they're done. Like I said, you can kind of usually, the telltale sign besides that smear is if you look on the bottom of a joint and you see kind of a little, not necessarily soldered like drip, but in other words, it's here the top, you can still see the line of the fitting. If on the bottom that's covered by like a little curve of solder, that's a refrigeration tech's joint. That's from not wiping the solder off as it's wet. You still want to go over it with a wet rag, just because if you don't, that flux will turn this green eventually. Okay, so let's see if we can get you a good view of this other joint here. A different type. Now obviously that one was on its side. This one is not. This one's more straight up and down, so this one's even easier. You'll see as I hit it with the heat and go around with the solder, it will puddle up and make pretty much a complete seal around that. You won't even tell it's a fitting. It'll be perfectly tapered through. Just like that. Oh, get a little bit of a drip there. And then we'll hit the one on the bottom of this, which you guys probably aren't going to be able to see. Like I said, this is the one that's kind of a pain in the butt, and these are the ones that you notice when you heat the fitting, the solder will draw into it. If you put too much solder in there, that's when you get the drips down the line. Let's see if I can do it without getting the drips. Got one little drip. Okay, I'll take you off the tripod there. We'll get a quick look at what we just did. Okay, going handheld here for a quick second. Here is our discharge line. There's our joint there, coming off. We're going up to our dryer right here. There's my little drip hickey right there. There's that other joint. You can see how it kind of forms a nice little tapered, joint. That means this whole thing is full of solder. We bend up with a 90. We go across, 90 down, 90 into our tank. Now, what I was talking about, that little drip, you can see right on the bottom of this fitting. That right there, that's from not wiping the joint. That would not be there if somebody wiped the joint with a wet cloth. Alright, so now we need to get our outlet here over and into our regulator. The only thing though is that regulator is going to be attached to the top of this, so I'm going to get the actual top of this bench on here, which is a wood core covered with sheet metal. So let me go get that. I'll put that in place so we can do everything at once. Okay, I got the regulator mounted over here. Here's the inlet, which is this is to fit a CO2 tank. I got an adapter that threaded into that, got me down to 3/8. This is a 3/8 process tube here, which has a 1/4 inch flared fitting on the end. We're going to come down here. We're going to go over. I'm probably going to come down at, I'm going to come down a little bit and then go along the inside of this so I have something to strap that pipe to. So I'm going to go down, I'm going to 90 over, 90 this way, and then 90 into that fitting right there. So let's figure out exactly, eyeball this to figure out how far down we gotta go. We're looking probably somewhere along the line of 4 inches. But there looks good. I need to bend. Inches over, we'll say. And looking at from there to there, 8 inches. That's there. Set in place. 8 inches. Right there. 90. Second here, get this out of the way so get that piece in there. And looking at right about there, in that neighborhood. Alright, let me cut this all up, cut this off, and clean the rest of the fittings up. Okay, we're all in place here. Not too shabby. Decently even. Not too bad for eyeballs. Alright, so now we're going to put our pressure control. I'm going to hook that in. There's a port right up top here. Might hear a hiss, that's going to be me breaking the vacuum. If I can get the cap off. Okay, I got it tightened up as best I can with my adjustable wrench. I put a filter on the air inlet. That's just a car fuel filter attached with a rubber hose. So I'll give it something. We go around to the front and I'll show you what I'm going to set the pressures at. Okay, this is just a standard refrigeration high pressure control. But we can set both the cut in and cut out. So we want it to cut in. Actually, I'm going to move the cutout first because it's going to move the whole rack. So we'll have a cutout of, say, I don't know, 200 psi. Sounds good for now. And that's 200 psi, and we'll cut it in at say 150 psi. So it'll go up to 200 psi, it'll shut off, and it'll go down to 150 psi and turn back on. Okay, I have a water and oil separator on the end of this. I have the regulator screw backed out all the way. This here is the tank pressure. This is my regulated pressure. So let's turn it on and let's see what happens. Compressor just turned on. Okay, we're getting there. Pressure's building up. About 100 psi there. 150. Gonna be shutting off pretty soon here. Okay, that's right at 200. Now I'm just gonna manually turn that screw to a lower pressure setting until it shuts off. There it is. It was about a quarter of a turn and I needed to turn it to shut it off. There's 200 pressure and holding. And here is my regulated pressure. It actually dumps the, I don't know if you noticed that, it dumps the pressure as I turn the screw. Let me see if I can get it over here. Okay, so I can actually turn this screw by hand. I don't even need a screwdriver. And there's my regulated pressure. Now when I turn it down, it'll actually dump the pressure off in the regulated side and bring it down. So let's turn it up to say 40. Well, let's do 50. Alrighty, let's see what that kicks that compressor back on at. Just kicked back on at, it's more closer to 175, so and give it another little adjust. That should be more like 150. So there we go with that. Now, I think I can probably mess with the pop-off valve on that tank. But to be honest with you, I don't particularly think I have to. Let me see if I can. I'll see if I can loosen it up a little bit and see if I can get the pressure to pop off. So give me a minute to experiment with that, and I'll let you know what I come up with. Oh, I can't really get at that valve. It's behind here. It's right on the back here, and I need a small spanner wrench, which I don't have. So I might play with that. I might not. You know, this tank is more than capable of holding 200 psi. But just for S&Gs, I'll probably get a spanner wrench and see what I come up with, and maybe I'll just update it when we figure that out. So I'll button everything up. I'll get a cover for that. I have the cover for this. I'll put that on there, and there's the regulator there. It does have one of those ring poles on the side. That's what this is. Those discharge valves. There's the switch. I got to get a new cover for this, for just a single switch in the middle. It's the only cover that I had. There's the oil and water separator, my hose, the unit itself, and then underneath here, that's the drain valve that we put in. And hang on, let me shut the switch off here. Come on. Get a little bit of water out of there. You can see on the floor. Yeah, that definitely lets me drain it out and drain any water that would be in that tank. So that's it. That's it for this video. And this bench is going to live over there next to my other one. And pretty much it for this project and this video. And we'll see you on the next one. Hope you guys enjoyed this.